Our next speaker, looking forward to this. I'm gonna not ramble on too much because we all need another coffee. So Nikita Kich from Tzafon, welcome.
Yeah, thanks everyone. So I'm from Tzafon. We're a research lab and we train foundation models for computer use. And then computer use is kind of underappreciated topic and it's now becoming hot. Big labs are working on this. We were kind of early on, and so I will try to kind of cover our journey here and what bottlenecks computer use. And of course, the upside is really high. People are interested in automating workflows. You know, we're always hear this talks about how you know, we're going to automate white collar work. I think this is kind of the way most players bet on this, and yeah, let's just take a look. So first of all, what I mean by automating, you know, workflows and computer use agents is just like a LLM acting like clicking for you and typing stuff for you. And so you install an app or something like this, and it somehow interacts with a computer on your behalf. Now the consensus here is I think best performing models, they all interact with computer by just, you know, it takes a screenshot and then it sends an action like click, I don't know, coordinates or like type something. It might seem like not the smartest way to do it, but it's actually not that bad compared to like the alternatives. And I think the consensus is, you know, that's how it operates. And now let's look at the you know, state of the art. What is going on? So there's not many benchmarks. There are not many good benchmarks. But I think the one that people are most looking at is OSWorld and related things. And again, computer users get more and more attention. You know, in latest release, Claude mentioned the first thing is OSWorld results. And just to get a sense of what we're dealing with, here's like a task that this is human interacting with computer, just showing the tasks. This is what model sees in a benchmark, and you know, it just has to, you know, restore some file from the trash, and that's the task we're dealing with. And here's the results of, you know, the SOTA models. And so as you can see, it's not really good. The task is really simple, and even in the best models, they kind of don't perform really well. But as I mentioned, even with simple workflows, the economic upside is really high. So yeah, that's kind of the background. And so we started with first principles. So we were like, well, how do we make a good computer use agent? We started around a year ago, and initially it seemed like relatively simple. So we're like, well, can we just like fine-tune on some successful trajectories, or like it shouldn't be that hard, we thought. So the first thing, we tried to be reasoned from like first principles, and the first thing we needed is some way to interact with computer, regardless of whether you want to SFT or you want to do some RL. You probably want a way to generate data at scale, and so that's kind of the first thing we did. This is. Yeah, that was our first idea, and so we released a WayPoint. WayPoint is like a way to interact with computer. Initially started with browsers, now we support OS. It's kind of a nice solution by itself. It's fast. It maintains a warm pool of browsers, so you don't have to like. It's really fast if you want to collect data. Here's a simple script. I can show you how you interact with computer. So here you can see a. You know, this is we released our SDK. It's really nice. You can, you know, this is you can just run it. Okay, my Wi-Fi is disconnected. Yes, I can just run it, and so that was the first kind of bottleneck that we solved. And you know, here we just take a screenshot, we do something random, and here's a screenshot that something happened in a computer. So that was our solution to kind of the problem of generating data. And so now as we can generate data, the idea is, well, why don't we just take some tasks, generate a lot of trajectories, take successful ones and either just SFT on them or do some kind of reinforcement learning. And it doesn't really it somewhat worked, but it didn't really scale well. There's a couple of problems here. So first of all, when you start generating trajectories, by trajectory I mean say you set some high level goal like buy me tickets, and the model would go on a website that would be the first node, then it goes further and further, and you get this sort of tree. The problem with it is it's kind of low entropy tree, so it would often just go with the one trajectory. The second problem is when we try to run it, because the models are they kind of they don't really understand computers, so it's hard to verify. When you build automatic verification, the rewards are really sparse. If you try to just ask ChatGPT whether the model accomplishes the task based on a screenshot, it doesn't really answer well. But the one that we've been able to make the agent work is in the domains with verifiable rewards. So say terminal tasks, like when you execute tasks on terminal, or like when you have HTML and you know exactly what the solution is. Like say you ask an agent to find something in the website and you know the concrete answer, then it kind of works quite well. So our first idea was we looked at the performance of existing models, and we're like, well, it seems like they don't really notice that when they do something stupid, they don't really come back. It would be really nice if there's like just a really smart model would divide the task into like a subtasks and maybe guide the model, a smaller model, and that seemed like a more natural task for like more NLP-like. Say when you assign a tasks, it seems like a task that you can learn with RL. Back in the days, there was previous speakers spoke about the post-training and pre-training, and there was no really good RL infrastructure back in the day, so we kind of had to implement it ourselves. It's kind of surprising that it's learned. So we took a supervisor model with Gemma, which gave instructions to a Quen, and we generated a lot of trajectories. We SFT'd on them. We did RL, and surprisingly it improved. So it was kind of a big deal because there was no infra, there was no it was quite new. But it didn't really scale, and the problem is the model. This approach doesn't really generalize. So when you train on terminal tasks, or like when you train on browsing file system, or like something like this, it doesn't really generalize to other domains. We examined like kind of the performance on the benchmarks, and there was common failures. Like say the model would understand where it should click, but not click the right thing, and you might think, well, it just doesn't understand the coordinates. And the issue is quite deeper. If you examine, say the model, there's a general grounding problem. Say the model wants to click some button, and it doesn't really recognize which button is correct one by the description, so it clicks just other buttons. So if you look at the distribution of errors by coordinates, it's either 0 or like a lot. So yeah, here's kind of the picture that illustrates it. So when you ask a model like click some button, it either it either clicks here or there. So it's like the error is large, and the problem is we played with it a lot, and the problem is the model doesn't really understand grounding. It kind of what you expect, because the way transformers process images, they just like they patch image into a grid, they flatten each part of the grid, and they basically treat it as tokens. And oftentimes most of the times the open source models, the way they train multimodal is they take a text-to-text part and they try to attach a vision part after text-to-text is pre-trained. So of course, as text-to-text part is really good, when we train on, say, image capturing data set, a lot of the variance is explained just by text-to-text part because it's so good. And the signal from images is quite bad. So we kind of felt like well, we need a fundamental solution here. So what we needed is to either throw a lot of the data in pre-training and or just fine-tune existing vision encoders on a lot of screenshot data. And we decided, well, why don't we just build a model from scratch? So we decided to pre-train a model. And the pre-training was covered quite extensively in the previous talk, but it was very much the same. So we took a data set, we filtered it, we did ablations, we did meat training, then we did RL, and so this is a standard cycle. But we still found the attaching vision encoder part is quite hard. So for now, we just took Qwen vision encoder, and because it's kind of the best of open source solutions, and we fine-tuned it on a lot of data from say tutorials where you have like a tutorial somewhere, and the person explains what is going on the screen. You would transcribe it, and we found this quite helpful, but it's still ongoing research. Yeah, this is aside. There's been a lot of infrastructure progress. Even half a year ago, the infrastructure was really poor. There's the pre-training and post-training was kind of hard. Nothing worked. Checkpointing didn't work. Now it's way better. So now there's the ones I really enjoyed, mostly TorchTitan and TorchForge from Meta. Those works really fine, and we don't have to deal with it ourselves anymore. It's really efficient, and we even achieved 40K tokens per second per GPU. It was SOTA at the moment with some modifications made to TorchTitan. Yeah, and we played a bit with pre-training. So we did a pre-train. A large part of it is in a PA. It's kind of yeah, people don't really do that, but we managed to make it work. We also are able to make mixture of experts converge. We do a lot of pre-training stuff now. So, but yeah, to summarize, now we kind of we're a small startup, so now we mostly are focused on releasing a model, which we pre-trained, and I'm not going to focus too much on pre-training because it's covered in the previous talk, and Olmo, the Hugging Face model, did a great job at describing the recipe here. So what you can expect is new model release, obviously, and an app for desktop. It's now in beta, and the agent would act on your behalf on your computer. I think it's kind of cool, but the things that you can use even now is the WayPoint, and for whatever task you want, it's as long as you need to collect a lot of data, and or like you want a fleet of browsers or lightweight Linuxes. That's a great solution. And yeah, that's pretty much everything I wanted to cover.